Hello, today is my open source 2022 talk on Ditch Your CICD 3 Ways to GitOps. We're going to be looking at avoiding CICD vendor lock-in by leveraging multi-stage Docker builds with GitOps, ArgoCD, and Argo Flux with both GCP Anthos and Azure Arc. We're going to compare some Cloud SaaS offerings and as well as some open source options, and we're going to use GitOps CD, Argo, etc. We're going to demonstrate multi-cloud deployments and moving our CI logic into our Docker build files. As I said, my name is Isaac Johnson. I grew up in Western Michigan and most of my life in Minnesota. I went to Michigan Tech and wrapped up my college at St. Thomas. I've been in the software industry for 25 years. I live in Woodbury with my wife and 3 daughters who are 10, 8, and almost 6. I've been steeped in the culture of build and releases. So I've been doing this as build engineer, release engineer, SCM, SMD, manager of SCM teams. I'm currently interim director of an engineering squad. I'm principal software architect as well. And I've also done cloud solutions architect. I'm actively Azure certified and I have been AWS certified in the past as well. Lastly, I'm an active blogger. You can find a lot of my writings at freshbrew.science. So before we can get into how we GitOps, we need to kind of level set and get a little bit of history. So the idea of software configuration management, DevOps, software reliability engineering, these concepts have been around since the 50s. So software configuration management, the precursor to DevOps, came out in the 1950s. It covers revision control, change management to software, and baseline configurations. And the key features of SCM are process management, build management, configuration management. In the mid-1980s, they started to add revision control systems to the mix. And we saw the 1980s capability maturity model move into the 1990s capability maturity model improved, or the CMMI. And a lot of these concepts for how we apply process comes out of the CMMI and lean engineering. I think the first time we saw a full suite was with Atria ClearCase, and so IBM ClearCase, IBM ClearQuest became a full suite of source code control as well as ticketing. The objective of SCM is to ensure a systematic and traceable software development process and that all changes are precisely managed, and that the software system is always in a well-defined state at all times. So let's kind of talk about the way traditionally time was spent. So before we kind of got to the DevOps journey, what we had is development was spent a lot of time with features, bugs, and technical debt. Your test or QA team would do all the integration tests, the regression tests, the performance tests. The deployment side was all focused on tracking changes. You had a change control board, you had deployment nights, you had monitoring tools, but the operations team was very separate from dev and test. These were 3 different silos. As we move towards that DevOps journey, what we started to see is the QA part of it, the integration and unit tests started to kind of come into play here on the dev side. The QA activities, by and large, were left to dev, and our DevOps practice started to add all these other features like tooling and ticketing and constraints. We got the deployment enhancements bundled into DevOps, the CICD system in DevOps. And so what happened with operations? That barrier broke down and operations became more about infrastructure as code, scaling, logging, monitoring, cost optimization. But a consequence of this, as we see, is maybe we lowered a little bit of the time to release in terms of time to deliver features with the resources. So we kind of got a better ROI out of dev. And obviously a better ROI out of operations. Less time was spent by having a fleet of network engineers or literally going to a data center and unracking and re-racking servers. But the cost became so many DevOps tools, so many CI/CD tools, so many false starts and relaunches and reworking, the new DevOps system being launched again. And all that maintenance added a lot of cost and time to systems. That SCM to DevOps journey really, you could argue, started in 2008, 2009 with Andrew Clay and Patrick Dubois. They were concerned with the drawbacks of Agile. They saw Agile being applied, but they didn't see it in the way software was being developed. And the first DevOps Days was launched in Belgium in 2009. We often talk about that's where DevOps started, 2009. When Gene Kim wrote the book Phoenix Project in 2014 and later the DevOps Handbook in 2016, that's really when the term started to become socialized. I recall hearing DevOps more around 2015, 2014. That was when it started kind of getting into my circles. Some of the key principles of DevOps is cultural change, agile philosophy with lean engineering. It's the practice that combines software development, but with IT operations. Sometimes they say it's if IT operations had to be done by a software engineer. We talk about continuous delivery with quality. And if we take SCM and Agile and marry them together, I argue that's kind of what you get with DevOps. So what are some of these patterns? And I'm laying this groundwork so you can see the history. The trends in the late 2000s and early 2010s was software was moving towards ops with continuous integration. We had things like Cruise Control, Hudson, which later became Jenkins. And these tools were used in that SCM, that little red dot in the middle. And that kind of was the intersect between software ops, project management, and QA. Operations started moving towards software with things like Puppet and Chef and Knife and Kitchen and all those tools. And we had the monitoring and rollback tooling started to be added. We started to think about how do we deploy reliably with automation. And that DevOps journey, we started to see project management kind of move away. This balloon here started to kind of move away. It wasn't such an intersect. And DevOps became that intersect. And QA exists, don't get me wrong, but QA as a practice started to come more around here. The next thing we started to see is that pattern into SRE. And with SRE, we see the DevOps being there with QA, but DevOps as a practice started to expand its domain. It started to muddy the water a little bit. And so we started to see DevOps being everything. It became this huge bubble here of all the things. But we still needed that practice to ensure that we had reliability engineering. And that's where it became SRE. And in many ways, in my head, SRE and SCM become very close, but with a focus on Agile and Cloud. As far as tooling goes, we started to see the growth of DevOps tooling. Revision control makers started to expand into DevOps suite. And so Perforce, IBM, Microsoft all came out with their full suites to handle all the things. And that's where we saw Puppet and Chef being married with Jenkins, and we saw these automation frameworks of Zephyr move into all the things. So here we have Jenkins can do all of these things. Circle can do all these things. Harness, Azure DevOps, GitLab, GitHub, CodeFresh, CloudBees, Atlassian Suite, Perforce. They all have full DevOps everything suites now. So you can get married to a vendor and get all that stuff in there. The other thing that we need to bring up is cloud computing. I mean, cloud computing arguably started with Amazon's launching of Simple Storage Solutions S3 in 2006. 2008, Azure first introduced Project Red Dog as their cloud compute. 2008, Google announced App Engine. But by 2010, 2011, 2012, all the cloud vendors started to have options. And what we see as an effect on SCM is we start to see installers and platform builds, being the things that we used to do, all of a sudden become infrastructure as code. This also created another problem. And that problem is DevOps became this magic illusion. Just sprinkle on the DevOps and it'll solve all the problems. Chef liked to use that term, sprinkle on the DevOps, as if that would just somehow magically fix all the problems. This brings us to GitOps. Like this is now why we're at the point of GitOps. GitOps has a few definitions. So GitOps is an operational framework that takes DevOps best practices used for application development, such as version control, collaboration, compliance, CICD, and applies them to infrastructure automation. That's the GitLab definition. We can also see Red Hat and CloudBees definitions here, but my definition might be unification of DevOps practices into a single consistent flow using Git and YAML. The reduction of disparate suites while avoiding vendor lock-in, and addressing infrastructure and application code in a unified revision control system, namely Git. Now this is that infinity loop you've seen a million times, the DevOps infinity loop, but it talks about code, build, test, release, then you do deploy, operate, monitor, plan, and back to code. It's that big loop. But the question you have to ask yourself is, the ops side still builds and tests their infrastructure as code, right? The ops side has a plan and a schedule, right? And the developers monitor on their deploys, right? It's not really separate dev and ops, as this diagram shows. So let me kind of introduce that concept I want to get to. It's the unification of systems. Operations and dev operate the same. So they might monitor with Datadog, right? And their code might be a little different. We might do .NET Core and Go and Docker files for the dev, and its infrastructure is coded with Ansible, Terraform, and Docker files for the operations side. But then we get a full suite. Azure DevOps and Terraform Enterprise can handle the build. The test is with Azure DevOps. The release is with Azure DevOps. The deploy is with Azure DevOps. We operate on Azure, maybe on-prem and GCP. And finally, we do Azure DevOps work items or Azure work items and boards. But it's not just Azure DevOps, right? I mean, this same concept goes everywhere. We get CloudWatch and SNS to monitor for the operations side, but we can use CloudWatch and SNS for the dev side too. As far as code goes, we can use HCL language for our operations code, Packer, CloudFormation, Docker files. The development might use Angular, Python, and Docker files. And now with the AWS suite, we could use code build and code pipeline for the tests and releases. We can use code deploy or code start for the deploy. AWS itself is where you're operating. And then you do need some sort of planning software. That's not offered. That is not offered by Amazon, so you'd use something like Jira. What if you use GitHub? GitHub, we could be monitoring with Sumo Logic, metrics and monitors, and the developers could be using dashboards and logs. As far as code goes, we use things like Crossplane and Docker files and NODEJS and Docker files. And then lastly, we use GitHub Actions for the build and the tests, and we could use GitHub Actions plus SONAR for the testing. Our releases with GitHub, our deploys with GitHub. We could operate in both Linode and on-prem. And lastly, we use GitHub projects for planning. So the theme that I'm trying to get to is the code and the monitors might be domain specific, as well as maybe operate. But everything else is plug and play. The plan, the build, the test, the release, deploy, the operate. GitLab, GitHub, Azure DevOps, Atlassian suites, they all can handle this. And so now you want to try to find a way to migrate between suites using Git and YAML to avoid vendor lock-in, right? So that's the benefits of GitOps. It's a system of record. All changes to configuration are there together in code. It allows the proper review and control of changes to infrastructure, tests, and deployments. We use feature flags to enable trunk-based development. This reduces branch complexity. That is, everything is live on main. You use a feature flag to enable or disable the features. We abstract the tooling and we reduce vendor lock-in. This allows cross-cloud migrations and transitions. Lastly, and this is a really key point, the authorization and authentication is consistent. The same people who can see and update the code that deploys and makes up the app are the same one who can see the tests and update the deployments, right? If you can see dev, you can update dev. And the part of the control comes down to the PR process. So your pull request is where you put your controls. You do your reviews and your PR process to apply controls. Now this allows me to revise my GitHub definition a little bit. It's applying release flow in Git and letting your revision control system be the source of truth for everything. Software, infrastructure, tests, deployment. These systems that automatically drive change from release flow in Git require minimal pipeline orchestration. That is, don't just rewrite your Jenkins file in yet another YAML-driven system. You can need to stop procedural deployments using hand-created and managed scripts. No more pets. So a question you might ask yourself is, am I already doing GitOps? Maybe I'm doing GitOps. Is the configuration of your destination environment, your cloud, on-prem, hybrid, something you can see in your Git repository or somebody with authorization could? Are changes to systems tracked in Git commits and deployed continuously? Do you have a set of unmanaged Jenkins? Now be honest, do you have a set of unmanaged Jenkins that you know about but don't tell IT or operations because it's how you get stuff done? Do you have long-lived branches because the changes got too darn big and now you have these side pipelines to deploy with very specific branches because you can't really update main? Be honest. All right, enough talk. I've shown you a lot of slides. Let's see some code. The first thing I want to tackle is the multi-stage Docker builds. I talked about moving the logic out of your CICD tooling into your Docker files. Now all this is documented here with some repos and deep dives, so please feel free to refer to this PowerPoint. You can see a more in-depth step-by-step guide here, and all the code I'm going to be referring to for these Docker files is there in that Docker with test2 repo. So the traditional containerized deployment started with coding, npm init, install. You'd create your JavaScript files. You might update your package JSON test, add a test and a run and different invocations, and then you'd create your Docker file. The CI, you'd build locally. You'd create some test gates, maybe in a Jenkins file or an Azure DevOps pipeline. You'd push the image gate if there's an error, and then you'd push it to a container registry if it's the right branch. And you could do all this stuff with Jenkins or GitLab or GitHub or Azure DevOps. As far as the CD part, you'd do a Docker push, and then you'd somehow track your Helm changes. You'd update a Helm deploy, add some values, manage secrets, and usually the deploy was handled with some kind of pipeline somewhere. As we talk about the GitOps containerized development, the code part has stayed the same. npm init, install, JavaScript, package JSON, Docker file, that's all the same. But the container registry could actually be used to do the GitOps part. You can build the container image in the container registry upon code change and handle your tagging. GitOps will deploy. Every time you change that branch, it goes out. It deploys on change, and it syncs when it's different. So let's kind of show an example. Here's a Docker file, very basic. You see it's a NODEJS 17.6. I have a work directory. I copy in my package JSON. I go ahead and do an npm CI. I have kind of that test tag if I want to do testing. And then I have a prod base right there for doing the production. That's how it actually runs. And next, we have our basic Node app with tests. So our server.js, I'm using Ronin. So there's a Ronin server with mocks. We see our test file right there. And lastly, we see a package JSON. You can see I'm using Mocha to test. And I use nodemon because that just monitors the changes. If I change the file, it relaunches it. You don't have to use the start command there for nodemon. And there, next we would actually run it. So here we see I use NVM. I always use NVM because I dance between versions of Node. But I'll set my Node version to 17.6. And next you'll see that I install some packages. So I install the packages in my package JSON. And now you can see building it. So with the building local file, you see it build and the times it takes. But if I do that target tag, so if you see this target test right here, then we can see that we're building all of our tests within the Docker file. So all my unit tests happen right there in the Docker file. Now you can expand this model. It's actually kind of fun. You can use things like SONAR to track your unit tests and apply coverage gates. So with SONAR, you can see the big thing going on here is I download the SONAR version, and I picked 4.7.0.27.47 because that matches my SONAR server in the back end. You can also see I went ahead and left my SONAR token in here because I don't care. It's about uploading results to a private endpoint. So great, you have a token. You can upload another round of results. So you can choose to set that in at build time, but I just chose to leave it in. And then I can basically do a grep to find out if it failed. So if it can't update, we stop right here. Here's our gate. If I can't upload to SONAR, or if SONAR gave me back a bad result, I could gate right there and kill it. The or true lets me kind of fail silently in this model. And then lastly, run. So what that means is when I run it with the test, SONAR kicks in, it bundles and runs my SONAR test in my Docker build, and we can see that we passed because I set a gate that was low. From there, I can see the code itself. So here we can see the coverage is a lot on the calculator.js, but none on the server. And I can go ahead and see that the coverage results on individual files. And that means SONAR shows you your source code, so you probably don't want it public unless your things that you're analyzing are open source. If it's open source, yeah, use an open public SONAR queue. But if it's private source, then you may want to put a password in front of your SONAR instance. Now, to do the really fun gating, you got to pay them some money. So, I mean, that is the idea of the open source, right? There's a bunch of stuff you get for free, but if you want more stuff, you need to pay for it. And in that case, the commercial features end up being things like gating, identity, the ability to gate at pull requests, branch controls, and there's linting as well as plugins. So I also talked about building an ACR. In this case, I'm using Azure Container Registry to use what's called a task to automatically build. So it's GitOps within ACR. So here you see I defined a task that says, build me 3 container images. This is the same container image, but 3 tags. And basically I'm tagging dev latest in a mutable tag, or a mutable tag that I can use for my GitOps. I do a run ID, and then it's a thing of mine. I always apply a tag of the git SHA to my containers. I've been doing it for all my time. To me, you should always put the SHA that was the source of your build on as a tag to your container so you have the traceability. So these things would have the same MD5 checksum because of the same image, but they'd have different tags. And I push all three, and we can see how I onboard this. Presently, ACR doesn't have a UI to onboard the GitOps trigger, but they will soon. So now I see it in my tasks. I can see over here that it's triggered on source control and automatically builds the container. We can see that the run IDs, and they're kind of funny, they call them CJ19. I have no idea why it's like that, but the run IDs are things like CJ19, and you can see that it succeeded, so I get all the task data. And here we can see it. So these three images are logically the same, they just have 3 tags, and so that dev latest gets updated with every build. Now, it's commercial, right? You are paying for ACR, it isn't free. And so you get things like metrics, so I can pull metrics right out of the metrics preview. I get logs out of Azure Logs and Analytics, so here's my pulling all the container registry events over time. I can also see webhooks, so in my case, I use webhooks with HookDeck to see the payload that's coming through, so I can have my ACR trigger something else. And I don't know how HookDeck makes money, if I'm to be honest, because it's a great tool. They give it all away for free. But I use HookDeck to send it, and I can see the payloads. I can dig into what was the JSON sent, so I can start to develop more complicated chained events. So here we can see what we get out of ACR when we're running HookDeck. As I said, ACR isn't free. My case, I spend about 20 bucks a month on this one container registry, and that's a mix of the Log Analytics workspace as well as the container registry itself. But I'm getting free builds out of there. It is GitOps, but it's not free, so it's a thing to point out. So now the meat of it. This is what I talked about before. 3 ways to GitOps. So we're going to talk about GCP Anthos. We're going to talk about AKS ACR GitOps, and we're going to talk about ArgoCD. And I want to point out GitOps, like DevOps, is a journey. We're moving progressively closer and closer to defining everything in Git, but we're not going to get all the way there. It's, as I said, it's a path that we're heading down. So we'll start with ArgoCD. And you can use ArgoCD hosted, or there are SaaS offerings. So with Argo, you have an orchestrator, the ArgoCD operator, and you can install it in your own cluster or a control cluster, or there's things like Acuity.io or Concrete.dev that'll offer you a hosted Argo. So in our demo, we're going to demo it with AWS EKS. We're going to use Concrete Dev hosted Argo, so I'll show you what that looks like. And the app that we're doing, and again, that's checked into that Docker with tests repo I mentioned earlier, is a simple Nginx Ronin Hello World example. So I'm going to go quick here, but I'm going to set up AWS EKS directly. So you need to do things like get your VPC out, your security groups. You need to list the roles and the subnets. You then need to define a cluster role and apply it. And then once you've gotten that cluster role defined, you could try to use it to launch EKS, but it won't work because you also need to get an IAM policy. But once you attach the IAM policy, it will create a cluster. Now that you have a cluster, you discover that, it's there, but there's no node pool. So it's, like a car without tires. So you go ahead and you create a new trust role. The trust role gets applied, and then you can create 3 new IAM policies for things like registry read and the node worker policy. Then you create the node pool, and you specify all these ARNs, and then you go ahead and verify that the cluster. And the key part here is we can see the nodes are listed right there. So we can get the nodes and see that the nodes have been created. A lot of times my quick verification that my Kubernetes is up and running is I get the namespace and I create a namespace. It's just a 1-2 punch to prove you can see things and do things. We're going to now go to Concrete Dev. So you can sign up with Google or sign up with a new account. I just use Google to keep it simple. I create a new workspace. A workspace kind of bundles all your Argo into one spot. So I did an open source North 2022 demo, and it tells you what the URL is going to be. We can see we then need to do all the setup locally. So I did homebrew install of ArgoCD on my command prompt. I set the endpoint. It does an OAuth, a pop-up browser, and click and then go back, and then we have authentication set up. And then we can do ArgoCD cluster add to add this. And I should just point out this right here just happens to be the entry in my kube config. So it could be default, it could be whatever your Kubernetes has added itself to the kube config. That's the profile name. We'll now see that it's been added right here. So now it's right here listed in my ArgoCD and Concrete Dev. And now I need to add a repo. So now on the command line, though I could also do this in the UI, I do an ArgoCD repo add, my Docker thing, a GitHub token, which is invalid now, and then it's a repository that I'm adding. We can see the steps to now add an app. So an app is the way that we orchestrate with ArgoCD. So here you can see that we have the Git repo, the full subfolder that has my YAMLs and my customizations with a K, which namespace I want to launch it to. I can decide whether to automatically sync or prune resources. So the skip schema validation I always check because sometimes I do complicated YAML and it gets caught up and I just want to say, ignore it, go. And then there's this thing I want to put, you know, they do want to make money, so they're kind of hounding you with that little chat thing. If you're on a full screen monitor, it's not so bad. And then you need to kind of set the name to be all lowercase. When I click add, it goes ahead and adds it. And what we'll see is the results. So now we're seeing an app get deployed, and I can see right here the node balancer is getting created. The load balancer is being created there for me. And it'll finally launch. But the problem is I had a rule with an image that wasn't being picked up, but it did launch successfully. We can see the app here, and it's also where we can delete an app. So we go ahead and click delete to delete an app. And once we click delete, what we'll see happen is you'll confirm it, and we'll see it delete all the resources. So when I hit OK here, it just starts to scrub it up. We can see the syncing, and then it'll sync to be removed. Now, if you create a namespace directly in the cluster, that won't be removed. It's only going to remove the stuff in the YAML. So here we can see that it's terminating the namespace because that was part of my YAML files. I can also come up here and refresh and see it deleted the load balancer, which is nice verification. When you're done, you're going to need to delete the node pool. This is if you're cleaning everything up. You're going to delete the node group, the node pool, everything else. If there's any errors, you're just going to need to fight through them because I had stuff where I couldn't delete the servers because they're part of a node group. The node group is still attached to Kubernetes, so I just had to repeat and fight till I got it all deleted. And then finally, you can delete the cluster. So next, we'll do Azure Kubernetes Service, same thing. Here I go ahead and set my subscription. I create a resource group. I like to create a service principal for RBAC. It's just my thing. So I create an SP. And if you do it again, it's idempotent. It'll just reset the password. So there you see me create the SP and then pull the password out to an environment variable. And now I just create the cluster. So of the three clouds, I always lean into Azure because I find it the easiest and simplest to get going with. All I got to do is, as you can see, set the account. I go ahead and set the resource group, and then once the resource group is created, because that bundles all the stuff it makes, I say, do the RBAC piece, create that service principal, and it'll warn me it's there before. It's just going to reset the credentials. And then lastly, I'll do an invocation to AZAKS create, and that will launch the cluster for me. And see, I missed the S on SP pass, but I do it again, and then we're good. And it goes ahead and creates the cluster. And once it's created, I can do a list. AZAKS list shows me the cluster. I can get the admin credentials. I can see the node. And here you can see the same thing I did before. List the namespace, create a namespace. My basic test that Kubernetes is up and running. Now I'm going to add it to ArgoCD. Now, pay that man his money, that whole slide before. First time I got an error, that's because the free version of Concrete Dev gives you one cluster per workspace. So the error there about RPC code is actually because I already had that AWS one assigned. So if you want to pay for Concrete Dev, it's $30 per month to have all the features and 20 applications and unlimited clusters. So if you're going to use a hosted Argo, $30 a month is a reasonable ask in my mind. So once I deleted AKS and then added it, you can see that my admin credential is added right here. Again, that's the name that my kubeconfig has for AKS. And we can then add the app as we did before, skipping schema validation. So far, all the steps are the same we did with EKS. And what I discovered is, hey, what's going on? I also didn't get ingress. I could see the one from AWS is the same as the one for Azure. Why is it not loading the site? So I did a little bit of looking, right? Realized I need to add an image pull secret. My kube configs, or my YAMLs, refer to an ACR that's private, not public. So you need to go ahead and set a password in here that you can pull out of ACR. And then you can get a replica set and see it satisfying the desired count. The other thing that I realized in testing, and it's just kind of logically I should have figured that out, don't put your namespace in your YAML. I mean, because you might move your YAMLs to different namespaces depending on usage. So hard coding the namespace in the YAML was something I also yanked out so it'd make it easier to deploy to different places. Once I did that, we could see it launched the full cluster. We have the Nginx, we have the service, the endpoint here, that's the public IP. We can see the pods and the replica set all deployed for us. And now when I go look at the load balancer, I get the IP address, and if I launch that IP address, there we see the Ronin server showing that it's been exposed. And what's kind of cool here is I can do things like change the namespace. So I went ahead and looked at app details. I did the manifest. I changed it to be that test123 namespace over to default. Again, all I'm changing is Argo here. Nothing in source code control. So I save it. And what we can do is we can do a get service. So we're going to show that we're running the application here in 201, 208 is the IP address in the test123 namespace, right? I go ahead and I save it. Or we're going to see almost immediately. You can see it going on behind the scenes, but as soon as I close this window, you'll see it. It tears it all down and launches all back up in the UI. We can see it all just sync, remove, and relaunch. And now if we go back, what we had seen of 208 here for test123, we'll see that there's now no pods in test123. And if I get all services, this one's being cleaned up. This one's trying to add. Now the old one is gone, and now a new one is there at 242. And if I go change my browser, we'll see that one won't load, but if I do 242, we'll see it goes ahead and loads, which shows Argo scrubbed it all up and relaunched it all, which is kind of the proof positive. Now cleanup is pretty easy with Azure. You can do AKS delete, the name of your cluster and the resource group, and then it'll delete it. Now let's talk about Azure Arc. So Azure Arc is a way to add mini Kubernetes services into Azure. And here we have Azure controlling with Azure Arc, and what we're going to be doing is the GitOps part of it, which is really Flux v2 or v1. So you can see all the Azure Arc enabled Kubernetes cluster. We're basically using Azure to be the orchestration layer, to be that ArgoCD, if you will. So here, the first thing I'm going to do is I'm going to try to do the quick start for EKS. Maybe that'll be less painful. So I do the size. I go ahead and deploy. It'll tell me what my total cost is going to be. And I can go into Azure Arc to start to add it. So I'll do these steps where I define the resource group and the cluster name. And then we can see that it went ahead and launched here. This came out of CloudCraft, so you can kind of see I've launched the whole infrastructure from AWS. Now the thing is, I got there, but then I decided, you know what? I did our Amazon already. Let's use one of my favorite cloud providers, Linode, or Akamai, I guess I should call them now. But Linode still exists. Love Linode. I launched an LKE cluster, which truthfully is K3S behind the scenes, but launched an LKE cluster. I went to add it to Azure Arc. You can see I already have my on-site K3S, which is some servers over here. And then I added LKE. Again, same steps. It basically gives you a wizard. You do AKS connected server and launch it, the command, and it just installs in there. So you can see it listed. Now I'm going to go to the cluster in the Azure portal and choose GitOps and choose Flux v1 or v2. v1's going away. So by the time you watch this, there may only be Flux version 2. For all I know, there'll be a Flux version 3. Then we go ahead and set our GitOps steps. So we set the configuration name, the namespace, right? And then we got to say the repo. So we have the repo, the branch, and the main. Now I tried public at first. It should have worked because it is a public GitHub repo. It just wouldn't. So I ended up going back to using my username and my GitHub token to access the repo here. You get to set your sync interval for how often you're going to sync Kubernetes or sync GitHub. So I said every 10 minutes with a timeout of 10 minutes. The next thing that you're going to do is set up your customization. That's kind of your application from our ArgoCD demo application. So here's the folder, K8s, how often I want to sync it every 10 minutes, a timeout of 10 minutes, and I can do a retry as well. You can choose prune, delete things that are, so if you delete a YAML, treat that as a deprecation, remove it as well, and force, just like that skip validation before, just do it anyway. I did find a nuance that the Flux v2 as deployed through Arc today is missing the ability for services to be modified, which came into play for me in a bunch of testing. So I gave you the YAML here for your cluster role changes that you need to apply to allow Flux to modify services. The other thing is I already know I'm going to need that Docker secret so I can access my ACR. So I went ahead and set that in the namespace before I got going. We see that indeed we launch it. It doesn't have as pretty a UI as ArgoCD, but I can see these objects created here. And now when we look, we can see the pods are deployed, and then we can see the services created right away, our cluster load balancer. Again, very easy, very fast change, and we can test the Ronin server right away. When I go to look where was the load balancer created, we actually see the load balancer is defined here in services and ingresses. However, it is a node balancer over in Linode, so I can see that the actual source IP address is defined inside of LKE. I should actually say inside of Linode. LKE is a feature. Another thing I'm going to point out real quick before I move on to Anthos is if you clean up in Linode and some of these other providers like Civo or DigitalOcean, it'll often clean up the Kubernetes, but things like your object storage or your node balancers need to be deleted by hand. So if you do demos using other cloud providers, make sure you look for load balancers or whatever the word is they use in that cloud provider, as well as your object storage for PVCs. So with GCP Anthos, what we're going to see here is you need to enable the API. That's how Google works for almost everything. Everything's an API you need to enable. And then you have a choice of where you can launch stuff. You can do GCP standard or autopilot. You can do other clouds, AWS and Azure. That's all that's supported. And you can do on-premises, VMware, or bare metal. Once you do, you set your project. You enable these 7 different services from GKE multi-cloud to connect. You need to go ahead in Azure, create a resource group. So we're going to create a resource group for all this stuff. You then need to create a VNet. So the VNet needs to be defined with some address prefixes. You also need this default subnet. It's going to come up later, but I named it default, but you can name it whatever you want. Next, you need to create a public IP address up front and a NAT gateway. The NAT gateway is going to come up later, so just remember that. And then we need to create a subnet with address prefixes as well. So we've now created the public IP NAT gateway and updated the subnet to use that NAT gateway. We're going to create an Azure AD app and then actually assign it some privileges. Now, I don't care about contributor and key vault, but I got a little particular about user access administrator. I feel that's maybe an excessive scope, but that's what they would like you to use. Contributor, user access administrator, and key vault administrator. Next, we're going to create the GCP Azure clients. Now, this is the client on the GCP side to point to Azure. So we get our subscription tenant and application. These are all Azureisms. Then we do the G-Cloud container Azure clients create my client. And this US East refers to the location in G-Cloud, not Azure. So it's a little confusing because in Azure I use US East 1, but in G-Cloud it's US East 4. And then I create the tenant, the application ID, and then it creates a certificate. So I get the certificate, and then I'm going to need that certificate because I got to patch. I got to apply the cert from G-Cloud over to Azure. So now I apply it to Azure, and I generate a PIM file out of it so I can get the public key. And I'm going to be using that public key for things like node pools and the control plane. So now I do the resource group, the VNet, the subnet, the key, setting all these environment variables here. And then it's just a typo. You see that the first time I did that, I should have said east with 1 T. And now I can actually create the cluster. And you do it with gcloud container Azure clusters, create the cluster name. And now I'm setting all the CIDR blocks. So I need to give it very explicit CIDRs to create. And we can see it actually creates the gcloud provider. And I was curious, what did it make? It's not using an Azure AKS. It's not the managed cluster on Azure. It's creating a cluster like you might do with KubeSpray, KubeADM, or Rancher, right? It's orchestrating on the side, just using Azure for the infrastructure layer. We see all these things made inside my Azure resource group. When I go back to Anthos, we're going to see it create. At first it's red, but it will turn green as it kind of comes online. And like before, I'm going to need to create node pools because right now I have 0 nodes. So there's nothing I can run here. But I can at least get some details out of the gcloud container command. So once we get the public key, and we can actually describe it to get the public key if we've moved on. In my case, I've moved on to another server by this point. I get the subnet, the public key, and now this is the command to create a node pool. And it's pretty easy. You're basically saying a name of a node pool, the min and max, and then I give it a node pool size. Again, this is using Azure syntax, standard DSV2s, and it creates the node pool. Once it's created, we can verify it. And now when I do kubectl get nodes, I see a couple of nodes have been created as I asked for. So let's kind of review some of the features. So some of the features we can get with Anthos are binary authorization, which validates the container images. That's called trusted images. We get Cloud Run, which is just Knative by another name. We get config management. This is GitOps. Again, it's using Flux, so same as Arc. We have ingress. I haven't figured out why ingress is different. If it's providing an ingress controller, it just didn't do much for me. Service mesh, or Anthos service mesh, which is just the commercial version of Istio. And an identity service, which allows us to use Google IAM. So if we go ahead and enable one, and so I'll pick something like enable on ingress, you'll see that it installs the feature, and sometimes it takes a couple minutes, but it runs from the portal to install the feature to the destination. I'm going to do the config management thing, just like Arc and ArgoCD. We go ahead and we pick the cluster to use. Then we enable policy control. Now, here's a big caveat. This is going to be adding OPA, okay? Or Open Policy Agent. And if you do this, which is kind of the standard fare, is to enable the policy agent, it's going to put all sorts of stuff in there. Hooks for, priority of operations. And the first time I did Anthos, I did it on my on-prem K3S cluster. And to this day, I've been unable to get all the OPA bits out. It's very hard to remove if you change your mind. So I'm all for policy controllers. Just be aware. Going in is easy. Coming out of this is pretty hard. So if you're testing, I tested on a cluster, you don't mind deleting or saying forever and ever it'll have OPA. Now we're going to set up config sync. This is the part that does the GitOps. So I'll pick my cluster, and then I go ahead and I start to set the config sync value. So here's the repo, the Docker test, the auth type. In this case, it did work without a password, but Azure hadn't. The branch, the path, this is the same as the customization folder, and the number of syncs. You don't get all the different bespoke settings as you did with Argo and Arc as far as timeout retries. So now I go ahead and get deployments, and I'm going to get the pods. Get the pods, and here you can see that I've gotten the pods and the test, and I see the IP address right there. So if I do kubectl get service, we can see there's the service, there's the IP address, and Ronin is running just fine. We see Anthos created a standard SKU, a public IP. And I did want to point something out because, well, Anthos doesn't cost that much, right? Your Azure infrastructure costs will. So you delete the container, you delete all this stuff. And when I deleted the cluster using the GCP commands, I was rather impressed because when we got done, I got back and obviously the VMs were removed. But all that was left were the 3 pieces we did as part of the pre-steps. The NAT gateway, the public IP address, and the virtual network. But the thing I forgot, a NAT gateway in Azure is a little teeny VM that runs all the time to be that NAT gateway. That meant coming back a week later, I'd already billed myself up about $16 out of pocket for this silly little VM. So the NAT gateway and the virtual machine behind the scenes comprise that cost. So delete the NAT gateway if you don't want to incur charges. So you can go delete the whole resource group, or you can pick all the things in the resource group and delete. That's what I did. Confirm yes, and then it's gone. So let's wrap up. We covered a lot. So what we covered is a history of DevOps. How do we get here from SCM to DevOps and DevOps to GitOps? So we kind of led that journey with history. We showed building and testing Docker container files. So we showed how we moved that, including SONAR tests in there. We talked about GitOps building with ACR and webhooks. And then lastly, we tackled 3 primary ways we can do GitOps. And they're not all inclusive. They're just 3 to show you. 2 of them are using Flux with GCP and Azure, and one of them is using ArgoCD with a hosted option for ArgoCD. As we think about moving forward, you're going to say, how do I get to DevOps? The first part you do is start to reduce your tools. You need to reduce the sprawl and the support. That's both time and cost for these different CICD tools. This helps you reduce vendor lock-in. You're not married into Jenkins files or Azure pipelines. Focus on those with an open source backend, or those that have open source options, because then you don't have totally locked in environments. Create patterns. As you start to roll this out to teams, use documentation patterns. I had a great architect at TurboTax who kind of taught me the idea of docs versus pubs, where docs are internal facing documentation, markdown files for your own team, and publications are external facing documentation for everybody. Start to build turnkey solutions, things that people can just hit a button and get an example. Use RESTful APIs for launching. And I like to move towards ticket-driven automation. We can see that in last year's Open Source North talk I did, a speaker series, showing a case of using support tickets in Azure Work Items to drive automations. Dog food it, right? Practice what you preach. It's easier to sell something that you've already bought. So if you're using GitOps for your own internal tooling, your SRE practice, it makes it easier to show a development team because you say, see, we use it ourselves. You're also going to find all your issues early. Those little holes, like the image pull secrets, you would have discovered early as you dog food it yourself. And then MVPs, minimal viable products, are your friend. You need a crawl, walk, run, scooter, skateboard, car, however you like to phrase it. Start small, work your way big, and you'll get there. Thank you so much for your time. Have a great day.